Okay, so this is a run through of GCSE papers Shadow Set 1, Higher Tier Paper 3, Tuesday 11th of June 2019. This is going to be a run through of all of the answers to all of the questions with fairly brief explanations, but some explanations nonetheless. So question 1, Venn diagram question. We're told that the full set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A is 1, 3, 7, 8 and 9. Set B is 3, 4, 5 and 9. And you need to put it into the Venn diagram. So always aim to start with the intersection part, this bit where it's overlapping. This is the part where A intersects with B. And you can see that 3 and 9 are in both A and B. So 3 and 9 are in both A and B. In the A, we still need to put the 1, the 7 and the 8 in. So 1, 7 and 8 go in A. And in B, we need to put the 4 and the 5 in. So we put the 4 and the 5 just in B. And then just double check. So A should have 1, 3, 7, 8, 9. 1, 3, 7, 8, 9. B should have 3, 4, 5, 9. 3, 4, 5, 9. Correct, they're in B. And we'd already checked A. And we needed to make sure we've got all the numbers from 1 to 9 included. So there's a 2 and a 6 that need to go outside the circles, but as part of the Venn diagram. And then as one final double check, have we got all the numbers from 1 to 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, they're all there. Okay, part B says, find the probability that the number chosen is in the set A intersect B. Well, as mentioned a minute ago or so, this part here is the set A intersect B. And how many numbers are in there? 2. Out of how many in total? 9. So therefore the answer is 2 out of 9, 2/9. Question 2. ELOC invests £300,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest ELOC will get at the end of the 4 years. So the starting amount increased by 1.5% for 4 years would mean that ELOC would have this much in his account at the end of the 4 years, £318,409.07. It's money, so we need to make sure we're giving it to 2 decimal places. The question actually asked how much interest he would get. So he started with 300,000. So the interest is the bit that he's earned on top of the 300,000. So that is £18,409.07. The difference between this and what we started with. Question number 3. We've got some information about the height of 80 plants. We need to find the class interval that contains the median. So class interval just means the group. So this is more than 10 up to and including 20, more than 20 up to and including 30, and so on. We want the one that contains the median. Well, there's 80 plants, so the median would be where they would accept where the 40th plant is. There's the first 11, there's the next 14, so you can see I've written some numbers here. 11, then plus 14 is 25, plus 16 is 41. So we've actually gone past the halfway point now. So the halfway plant must have been in this group, must have been in this class interval. So there's the answer. Part B is to draw a frequency polygon. So frequency polygons should be drawn with straight lines. They should be drawn at the midpoint of each group. And you definitely do not start down here and end over here. This is what a frequency polygon should look like. So we know that the 10 to 20, the frequency was 11. So midpoint between 10 and 20 is 15, and this goes up to 11. Okay, the next one was 20 to 30, and it needed to go up to 14. So 20 to 30, the midpoint would be at 25, and need to go up to 14, and so on. So then you just plot these points here with the midpoint, join it up with a straight line with a ruler, finished. Question number 4. Matt has drawn a time series graph to show the numbers in thousands of visitors to a fun park, and you just needed to find some things that are wrong with it. Okay, so the first thing that I've written, you needed to find 2 things. I've written 3 things down. So I've written the first one is that points should be drawn with a straight line. So could have just been drawn with straight lines. Point 2, I've said 9.5 is not on the vertical axis. So if you notice, it goes 6, 6.5, 7, 7.5, 8, 8.5, 9, and then there should be a 9.5 and then 10. So 9.5, this axis doesn't have all the numbers on. I've also said that they don't actually give you any information about the first quarter. So second quarter, third quarter, fourth quarter, and then there should be something for the first quarter. Second, third, fourth, first quarter. There's not actually a point for the first quarter. So those were the 3 things that I found incorrect with, or misleading for this graph. Question number 5. Question number 5 says we've got a hexagon. Hexagon's got 1 line of symmetry, which must be straight down the middle here, and you're told some information. These 2 lengths are equal to each other, these 2 lengths are equal to each other, and angle ABC is 114, and you're told that BCD is double angle CDE. You needed to work out the angle AFE. So the first thing that I've said is that 6 sides, so the sum of the interior angles must be 720 degrees. And I've got that because I've done, I've used this formula, taken 2 away from the number of sides, multiplied it by 180, and that's because I could split this shape into 1, 2, 3, and then 4 triangles. If I put a slight line on, might be able to see, I would have 1 triangle here, 2 triangles, 3 triangles, 4 triangles. So this was split into 4 triangles, which is why we do 4. N would be 6 sides, so 6 take 2 is 4. 4 times 180, and 4 times 180 is 720. So that means I know the angles inside this shape add up to 720. And then all I've done is set up an equation. And you can see I've put 2x and x on there. That's because we're told that BCD is double CDE. So that has to be double that. So I've just called that x and that 2x. And then it's got to be the same over here because we're told it's symmetrical. So now I've just set up an equation. So 6x plus 228 is 720. That comes direct from the diagram. 1, 2, 3, 4, 5, 6x plus 228. Okay, and it's just an equation to solve. 6x plus 228 is 720. So take away 228 from both sides, divide both sides by 6, and you find out that x is 82, which means that this is 82 and this is 82. Our task, of course, was to work out what this angle is. So if this is 82, it's got to be double it. It's got to be 164. Okay, so it's 164. Number 6, cylinder question here. So Wilson's got 3 tanks to completely to cover with paint. Each one is a cylinder, circle on the top and bottom. We're given the diameter and the height. He's got 8 tins of paint, and each tin of paint covers 5 meters squared. Has he got enough? Okay, so I'm working out the surface area of one of the cylinders. Okay, so you can see I've done pi times radius squared times 2, because that means I've got this pi times radius squared is the area of a circle. So I've got a circle on the top and I've got a circle on the bottom. The radius is 0.85 because half of the diameter, half of the diameter. So pi times radius squared is 1 circle, but of course I've times it by 2 because we've got a circle on the top and a circle on the bottom. So there's the top and bottom. I've then got the curved surface area. So that is pi times diameter to give me the circumference of the circle, and then times by the height. Now, if I just pick up an old piece of paper, you can you might need reminding that if I think about the curved surface area, comes about because we need the circumference of this circle multiplied by the height. Okay, so that would tell me the surface area going around the side of the tin, and then that would be the total of the surface area. So we've got the circle on the top and bottom, we've got the curved surface area and our total. Okay, and of course this would be meters squared, but Wilson's got 3 of those, so we need to multiply that by 3. So therefore we know that he needs 42.4586 meters squared of paint. Of course Wilson has got 8 tins, and each one covers 5 square meters, so he's got 40 square meters of paint, so he doesn't have enough. Okay, so that question was all about being able to find the surface area of a cylinder and then apply it to this particular question. So surface area of a cylinder was what that question was all about. Number 7. This one's a case of getting everything typed accurately into a calculator. So there's the answer, but what I'll also do is I'll just show you how I'm going to type that onto the calculator. So I would type that, press my square root button, press my fraction button, 2.5 multiplied by sine 41, close that bracket, and then the denominator, 9.2 squared, take away 51.5. So the calculator literally says exactly as the exam paper says. Press equals, and there's the answer. So the full display, and then also rounded to 3 significant figures. Next question, number 8. Number 8, we've got a right angle triangle and Sarah's trying to find the length of BC. Well, actually AC is the hypotenuse here, so if you're trying to find one of the shorter sides you should have subtracted, so it would have been 4 squared subtract 3 squared to find what BC squared was. Sarah should have subtracted. Question, this is next part of question 8, and it says Raymond's going to enlarge triangle PQR with centre C and scale factor 2. He draws triangle XYZ. Why is he not correct? Well, he's not correct because Raymond's actually not used the scale factor 2. He's used a scale factor 2.5. Okay, because this length here is not double this. It's this one times 2.5 gives this one. Okay, so he's used a scale factor 2.5 instead of a scale factor 2. Or you could have sort of said if you do I've done that length divided by this length, so xy divided by pq. That would equal, if he'd done it correctly and it was a scale factor 2, then this divided by this would be 2. However, as I've written there, length xy, that should be make that clear, length xy divided by length pq is not 2, so it's not correct. Okay, moving on to question number 9. Question number 9, a company has to make a large number of boxes. Company has got 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. Table gives the number of machines working on each day. So on the first day, only 2 of the machines were working, right, out of 6. So 4 machines weren't working. Second day, again, only 2 were working, so 4 machines weren't. And third day, again, only 2 were working, 4 machines weren't. And all the other days, everything else was working. So you can see my full working. Now, there are a number of different ways that you can go about doing this question. Okay, so I'll allow you time to read that one, the method that I've chosen. I've said that 9 days times 6 machines is 54 machine days required in total. On the first 3 days, only a third of the machines are operational, which means 2/3 of them were not working. And therefore, on 2/3 of those first 3 days, they've produced no boxes. Okay, 2/3 of those first 3 days is 2 days. So that means there's 2 extra days that were required, and therefore, and instead of it being 9 days, it's actually 9 plus 2, which is 11 days that are required to make all the boxes. Question number 10. So it says that Madeline invests £8,000 in an account for 1 year. At the end of the year, interest is added to the account, but you need to pay tax on the interest that you've earned. The tax is paid at a rate of 20%. So Madeline pays £35.20 in tax. You need to work out what the percentage interest rate was on the account. So I've said that 20% of the interest is £35.20. So that means 20% of something is £35.20. So I've written that as an equation, really. 20% of something is £35.20, or 0.2 times x is £35.20. And then if we just divide by 0.2, we'll find out what x is. And it comes out, using a calculator, that x is £176. So what that means is that Madeline earned £176 interest. Okay, so now you just need to work out what was the interest rate. So she had 8, you needed to say it's 176 out of 8,000, comes out to be 2.2. Okay, 176 out of 8,000 comes out to be 2.2, which means the interest rate must have been 2.2. So 176 is 2.2% of 8,000. So the interest rate for the account was 2.2%. Question number 11, just working with standard form, and don't forget, it's a calculator paper. Okay, so it's just about using the speed, distance, time formula triangle. So speed, distance, time formula triangle. How long did the signal take? Well, how long it is to do with the time. Time is equal to distance over speed. The distance was 4 times 10 to the power 7. And the speed was 3 times 10 to the power 5. Okay, it was in kilometres, and this was in kilometres. There was no awkward conversions to be made. So, and it wanted an answer in seconds, and this was in seconds. So again, no awkward conversions to be made. Simple case of just doing distance divided by speed. You can use a calculator. And again, what I'll do is I'll show you how to make sure you do type that in properly. Again, you could use the fraction button. 4 times 10 to the power 7 divided by 3 times 10 to the power 5 comes out to be 133.3 recurring. Okay, just make sure you use the calculator appropriately. And the next part of the question just simply said that the speed of the signal sent from Earth to Venus was actually less than what was given, so it was slower. So if the speed was slower, then it would take longer. The signal would take longer to get from Earth to Venus. Okay. Part 12. Patrick has to work out the exact value of 36 to the power half. He says a half of 36 is 18. So 36 to the power half is 18. What's wrong? Power half means square root. So Patrick should have found the square root. Okay, and then I've actually done it. 36 to the power half means do the square root of 36, which is 6. Question number 13. Density of ethanol, density of propylene, and making up some antifreeze. So we're given various different quantities, densities, and quantities. So the antifreeze density is going to be the total mass divided by the total volume from my mass density volume formula triangle. you need to know that 1 litre is 1,000 cubic centimetres. That's a fact that you need to know. That's come up a few times in this series of exams. So therefore 60 litres, so 60 litres of ethanol, 60 litres must be 60,000 centimetres cubed, and 128 litres of propylene is 128,000 centimetres cubed. Okay, so these numbers are going to be used in the rest of this calculation. So the ethanol mass, so mass is density times volume. So we're given the density, we've worked out the volume, density times volume, 66,600. Same thing for propylene. We're looking for the mass, so mass is density times volume. And the density is 0.98 given in the question. The volume is 128,000, which we've worked out. Multiply them together and we get 125,440. So therefore the total mass of these two ethanol and propylene mixed together is 192,040 grams. Just added them together, right? And now we can just work out the density being the total mass divided by the total volume. So the total mass here, the total volume 188,000. Of course, that will be these two things added together, and we can work out that the density comes out to be 1.021489, and to 2 decimal places 1.02. Question number 14. Question number 14. So we've got a rectangle A, B, D, E, and a triangle on this side and a triangle on that side. The first thing that you need to be aware of is that these are not right angle triangles, so there's nothing to tell us that they're right angle triangles. Okay. Tells the area of the rectangle is the same as these two triangles added together. Okay, and we're also told that length AB to length AE is in the ratio 1:3, and that's where I've put that x and 3x. Okay, because if this is x, this is 3x. Okay, for example, if this was 5, this would be 15. Okay, but we don't know what they are, so I've called them x and 3x, and then we'll use this later on in the question. Okay, so first thing that I've done is I've put my ratios in and then added them on the diagram. I've actually redrawn out this triangle on the side, AFE. So there's the 26 that was given. There's the 3x. So this is just a copy of this one here, 26 and 3x, 26, 3x. Okay. So I've then started using this algebra to work out the area of the rectangle and each of the triangles. So I've started doing this over here. So the area of the rectangle, this times this, x times 3x, 3x squared. The area of one of the triangles, right now, as I said, because it's not a right angle triangle, we're having to use the half AB sine C rule. Okay, area of a triangle being 1/2 AB sine C. And this is the area of any triangle. Okay, you need to be able to use that formula. So area of any triangle, half AB sine C, so half times 26 times 3x times sine 30. Okay, from this triangle here, or this one here. So half times 26 times 3x times sine 30. I've then sort of simplified it a little bit, so half of 26 is 13, and sine 30 is a half. Right, remember it's a calculator paper, you know, if you're not sure, sine 30 is a half. Okay, so sine 30 has been replaced with a half times 26 has been replaced with 13. Then we've got 13 times 3x, which is 39x, and then a half of it. So the area of one triangle is 39x over 2. But we want the area of both of them. So that's this times by 2, which is just 39x. So the area of both triangles is 39x, right? Remember, we're looking, we know that the area of the rectangle is equal to the area of this triangle plus the area of this triangle, and they're the same. Okay, so that's why I've done that part there. So now I've got my area of my rectangle, 3x squared, and I've got the area of two triangles, 39x, set them equal to each other. Remember, it says that they're equal to each other. And then solve this equation. Okay, so 3x squared equals 39x. I've divided both sides by 3. X squared is 13x. Set it equal to 0, factorised it, and come out that x is either 13 or 0. It can't be 0 because it's a length, so therefore x has to be 13. X has to be 13 centimetres. Okay, question number 15. Question number 15. It says the graph of the curve C with equation y equals fx is transformed to give the graph of the curve S with equation y equals f of minus x plus 3. We're told the point C has got coordinates 7, 2, and it's mapped to the point Q on curve S. Okay, so if we've got f of minus x, that means it's going to be reflected in the y-axis, and then if we add 3 on, it's going to be moved up 3 spaces. So there's the point 7, 2. If I reflect it in the y-axis, I'd get minus 7, 2, and then if I move that up 3 spaces, I will get to minus 7, 5. And so that point there, minus 7, 5, is the answer to the question. Question 16, a question about quadratic sequences. Now, there are a few different methods that you can use to do quadratic sequences. This is the method that I use. However, I'm aware of at least 4 methods. Okay, so I take my sequence, I find the first difference. So the difference between these numbers is 6, and it's 10, 14, 18, and 22. Okay, and if you notice, I've deliberately written that in the middle. Okay, I then find what is called the second difference. That's the difference between the differences. So the difference between 6 and 10 is 4, 4, 4, and 4. And you should always find that will be the same number. If that didn't come out to all be 4, I'd have known something went wrong. Okay, it needs to be a consistent number. Okay, and once I've got my second difference, I can then instantly get the first term of the answer, because it's always half of whatever that is, n squared. So because that's a 4, it's 2n squared. If that was a 10, it'd be 5n squared. If that was a 12, it'd be 6n squared. But it's a 4, so the first part of our answer is 2n squared. Next thing is actually take what that term was, so it's 2n squared, and write that over here, 2 times n squared. So I do 2 times 1 squared, so 2 times 1 squared, then 2 times 2 squared, 2 times 3 squared, 2 times 4 squared, 2 times 5 squared, 2 times 6 squared. Okay, 2 times 1 squared, 2 times 2 squared, 2 times 3 squared, 2 times 4 squared, 2 times 5 squared, 2 times 6 squared. Then the final step is to do the subtraction. So that's the original sequence, subtract that last line. So 5 take away 2, 3, 11 take away 8, 3, 21 take away 18, 3. In this case, they're just all 3s. So because they've all come out to just be 3, it's just a plus 3 on the end. Okay. Sometimes this comes out to be a sequence, like a linear sequence of its own. So you might have it might have come out to be a linear sequence, and you just find the nth term. It might have been 2n plus 4 or something. In which case you just write that down here. But because it's one constant number, that's the last part. Okay, so this answer is 2n squared plus 3. Question 17 is a graph matching question. So one or two of these should be fairly obvious. Okay, I think the first one that springs out here is this one here. I think this one, you know, this up and down, recurring oscillating graph is a trigonometric graph, right? Y equals sine x or y equals cos x always go up and down, up and down. So A is a trigonometric function. Okay. The next one that I spotted is this one, D, right? This is an exponential graph. It's going up and up and up. Okay, so exponential is D. This one is an inversely proportional graph, So graph B is inversely proportional, and this one is directly proportional. This is a square root graph. This is what, for example, y equals the square root of x looks like. Okay, so this is a square root graph. Okay, so you should have got DCBA. Question 18 is a question all about your algebra. If you're good at multiplying out brackets, then this is a nice 3 marks for you. Okay, so we've got 3 brackets, right, and do it in stages. So what I've done is I've multiplied out the first 2. So just multiply out double brackets, 2x plus 3 and x plus 3. If I multiply those 2 brackets together, I will get this, and I've then simplified it to get 2x squared plus 9x plus 9. So then I need to do 2x squared plus 9x plus 9 multiplied by this final term, final expression, 3x take 9. So again, I've just done myself another grid, 2x squared positive 9x positive 9 multiplied by 3x minus 9. And you'll get these terms, which simplify to give you 6x cubed plus 9x squared minus 54x, take away 81. Question 18b is a quadratic inequality question. So I've got rid of the fraction first by multiplying both sides by 25. You need to be really careful here, because this is a double bracket and you do powers before you do multiplication. So you can see I've written out my double brackets together, okay, and then multiplied out my double brackets, then multiplied everything by 25. So I got that. Okay. I've then set it equal to 0 because it's like a quadratic equation, except it's a quadratic inequality. So just like a quadratic equation, you solve it when it's equal to 0. A quadratic inequality, you do similar. So I've taken away 16 from both sides, and I've written it in the more traditional order. The x squared term, the x term, the constant number term, and then less than 0. Okay, factorised it. So this quadratic expression factorises to these 2 brackets. These would be my 2 solutions for these 2 brackets. I'd have positive 9 over 5 and I'd have positive 1 over 5. Okay, and from your knowledge of sketching quadratic graphs, we'd know that we've got a positive quadratic, so it would be a U shape, and we'd know it cut the x-axis at 9 over 5 and 1 over 5. Okay, so it cuts it at like 1 4/5, 9 5/5 is 1 4/5, and at 1/5. So that's what this quadratic curve would look like. And what we're looking for is, where is it less than 0, as in where is it below the x-axis? Well, it's below the x-axis at these points. It's below the x-axis here. Okay, below the x-axis there, and that means when the x value, remember that's the x-axis, when the x value is greater than 1/5 but less than 9/5. So when x is between these 2 values, and that's what this inequality says, that x is between 1/5 and 9/5. Okay, so it doesn't include it because we didn't have the less than or equal to sign in the question, so we don't need a less than or equal to sign in the answer. So it goes between 1/5 and 9/5. Okay, question number 19. Question number 19 is a upper and lower bounds question. So we're told that U is 26.4 to 3 significant figures. We're told that A is 4.4 to 2 significant figures, and you need to calculate the upper bound for the value of D. So D is U squared over 2A. So I've started by writing out what U could be. U could be anything from 26.35 up to anything less than 26.45. And A again could be anything from 4.35 up to anything just less than 4.45. Okay, so those are my upper and lower bounds for U and A. Now we need to find an upper bound for D. So what we need to do is maximize the numerator and divide it by the minimum possible denominator to find a maximum value for D. We need the biggest possible thing divided by the smallest possible thing. So the biggest possible value of U is 26.45, okay? And the smallest possible value of A is 4.35, okay? So we need to do 26.45 squared, because it's U squared, divided by 2A, so divided by 2 lots of 4.35, and we end up with this. We end up with 80.4140846. But the question actually asks us to give our final answer correct to 6 significant figures. So 1, 2, 3, 4, 5, 6. Round that number there, goes up to a 1, and there's our final answer, 80.4141. The final part to this question says the lower bound for the value of D is 79.8072, correct to 6SF, and it says by considering bounds write down the value of D to a suitable degree of accuracy. Well, it's 80. It's 80 because the upper bound would round to 80 and the lower bound would also round to 80, okay? And that would be whether we did it to 1 significant figure, they would both round to 80. If we did it to 2 significant figures, they would still both round to 80. If we go to 3 significant figures, then it would be 80.4 and 79.8. So what we want to do is find what they will both round to, and these will both round to 80, to 1 significant figure and 2 significant figures. They'll both round to 80. The upper and lower bound will both round to 80. So that's the answer of D, to a suitable degree of accuracy. Okay, number 20. Number 20 is a quadratic simultaneous equation. Okay, so we know that x squared take 4y squared is 9. I called that equation 1. And we know that 3x plus 4y is 7. I've called that equation 2. Now this is a tricky one because when we rearrange this, we end up with a fraction, and there's no other way of rearranging it without having a fraction involved. Okay, so when you have a simultaneous equation where one of them's got a quadratic term in it, right, you need to take the linear equation and you need to rearrange it so that you've got either x equals something or y equals something. So you need to make either x or y the subject of the formula and then substitute that expression into the quadratic equation. Okay, so what I've done is I've rearranged this one, equation 2, so that I find out that x is equal to 7 take 4y divided by 3. Okay, so I've taken away 4y from both sides. I've then divided both sides by 3. Okay, and I then take that value of x, that equivalent expression for x, and substitute it in place of this x here. And the reason I do that is because now I'll have an equation which has only got y's in it. Okay, it's only got one variable in it. It's only got one unknown in it. Okay, so instead of having x squared take 4y squared equals 9, I've actually got this, which is x squared take 4y equals 9. Okay, now this then looks a bit tricky, and it still looks a little bit tricky if you're looking ahead, but actually it's not too bad, right? So 7 take 4y divided by 3 squared just means 7 take 4y divided by 3 multiplied by 7 take 4y divided by 3. And if I just take the numerator, then I've just got this bracket multiplied by this bracket. Okay, and I'm going to get 49 take away 28y take away 28y plus 16y squared, and the denominator will give me 3 times 3, which is 9. And if I simplify the numerator, it's just going to give me 49 minus 56y plus 16y squared, all divided by 9. So I've now got 49 minus 56y plus 16y squared, all divided by 9. Take away 4y squared equals 9. So all I've done there is put my x squared, put my x back into here. Okay, so I've now got an equation which has only got, it's only got y's in it. It's only got y's in it. Okay, so I've just taken this and put it back here. Remember, this part here is this part here. So I've just replaced that down here. So I want to get rid of this fraction now, and I've got rid of this fraction by multiplying through by 9. So if I multiply this by 9, it just gets rid of the fraction, but of course I need to multiply this term by 9 and this term by 9, and that's going to give me this equation here. So 49 minus 56y plus 16y squared, take 36y equals 81, multiplying everything by 9. Because we've now got a quadratic equation, we solve quadratic equations by setting them equal to 0. I've rearranged this to give me 20y squared plus 56y plus 32. Okay, I've set it equal to 0, and I end up with this equation here. I've noticed that these are all divisible by 4. Everything's divisible by 4, so I've done that. And I end up with 5y squared plus 14y plus 8. That factorises to give me these two brackets. And then from there, I've got my 2y solution. So y is minus 2 and y is minus 4/5. Okay. Now, we know from what we did further up the page that x is equal to 7 take away 4y, all divided by 3. So all I need to do is substitute my values of y in, and I'll be able to find out what x is. So when y is minus 4/5, x is 7 take away 4 lots of minus 4/5, all divided by 3. Again, it's a calculator paper, so it really does not need to cause any kind of problems. So 7 take away 4 lots of minus 4/5, all divided by 3, and that's where I got my 17/5 from. 17/5 or 3.4. So if I put equals 3.4 there, and then the same sort of thing down here, but with whole numbers, it just comes out to be 5. So there are our solutions. When y is minus 4/5, x is 17/5 or 3.4, and when y is minus 2, x is positive 5. Okay, question number 21, histogram question. Histogram gives information about the distribution of the weights of some onions grown by a farmer. So we've got a histogram here. It's got frequency density at the side, which is always at the side on a histogram, and we've got the weights, which is a continuous piece of data going across the bottom, across the x-axis. So we're told in the question that onions less than 60 grams in weight are used for pickling. Onions greater than 120 grams in weight are sold at the market, and the rest of them are sent to the food processing factory. Right, this bit here, area of a histogram bar represents a frequency. That's key, that the area of a histogram bar represents the frequency. So all I've done here is worked out the area of each of these rectangles. So this one, 60 times 2, means that bit there is 120 onions. This one, 30 times 5, 150 onions. 30 times 9, 270 onions. 15 times 6 is 90 onions, and 45 times 2 is 90 onions. Okay, so I've then worked out there's 720 onions in total, and that would mean that 120 are pickled because 120 weigh less than 60 grams. It would mean 180 are sold at the market because 180 weigh more than 120 grams. Remember, it said that in the question. And the rest are sent to processing, so that must be 420 because these and these are sent to processing. Okay, and we can then use that information to help us with this part here, which now becomes relatively straightforward. The pie chart part of this question is the easy part. We're told that there's the pie chart representing the same set of data. The angle for the sector of the onions sold at the market is X. What is it? So the onions that were sold at the market, if you remember, I've got 180 sold at the market. So 180 out of 720, if you remember, there were 720 in total. 180 out of 720 multiplied by 360, that's got to be 90 degrees. 90 degrees. Okay, question 22. We've got a diagram, we've got a circle, we've got a point on the circumference of the circle. We know that this point B is 18 along and it's on the axis. We know that this angle here is 30. We've got a tangent to the circle, so this OA must be the radius. And if this is a tangent, it means that that has to be a right angle. Okay, and if that's a right angle, it means we've got a right angle triangle, right? Which means there's a fair old chance we're going to use Pythagoras or trigonometry at some stage now, because we've used a mathematical fact to state that this is a right angle. And as if I scroll further down, you can see that we are going to use some trigonometry in this question. So we know that B is 18, 0, P is 3P, P, and we need to find the value of that coordinate up there. We need to find what P is. Okay, so all I've done is redrawn my right angle triangle down here. So I've just sort of turned it a bit. I've put OAB. And we now know that this has to be 18, it's not 18 centimetres necessarily, it's just 18 units because it's just 18 of these coordinate units. So this would be the hypotenuse, 18 across there from O to B. So on here from O to B. We don't know what that one is, and I'm going to try and find out what OA is because I want to find out what the radius of this circle is. Okay. So if I can find out the radius of the circle, I can then begin to do more work with the circle. So you can see what I've done here. I've used my SOHCAHTOA triangles. Use trigonometry to find the radius of the circle OA. So some fairly basic right angle triangle trigonometry. It's a sine question. We're trying to find the opposite. So it's a sine of the angle multiplied by the hypotenuse. So it comes out to be 9. So the radius of the circle is 9 units. Okay, 9 units. I've then just used the equation of a circle. So equation of a circle, which is x squared plus y squared equals the radius squared. So equation of a circle, x squared plus y squared equals r squared. Okay, so I've now used that with my points 3pp. Okay, so the x coordinate is 3p, the y coordinate is p, and I've just used the equation of a circle. X squared plus y squared equals the radius squared. 3p squared is 3p times 3p, 9p squared. Got the p squared, 9 squared is 81, so this just becomes 10p squared is 81. If I divide both sides by 10, I get that p squared is 8.1. I then square root it to find out that p is 2.846049, and that is 2.8 to 1 decimal place, which is what it asks for, 1 decimal place. So 2.8 is the answer for p. And the final question, question 23. We've got the diagram shows the position of 3 towns, town B, C and D. Okay, and what we've got is that Cantwell, town C, is 7 kilometres from Birr on a bearing of 057. Downton is 8 kilometres from Cantwell on a bearing of 211. And we need to find the bearing of Downton from Birr. So we need to find what this angle here is. We need to find this angle going round there. So really, we just need to find this angle here that I put called Y, because it's going to be 57 plus this. And that would tell us the bearing of Downton from Birr. Remember, bearings are measured in a clockwise direction from north. So really, if my pencil's going up there, I need to work out what that angle there is. Okay. So from the last question, bearings, it's going to almost certainly, if you get a question like this, you're going to be using some form of higher level trigonometry, cosine rule, sine rule, that type of thing. Okay, so the first bits that I've written in here is that the bearing of B from C must be 123 because the bearing of C from B is 57. Okay, and that's just that just comes from your work on angles in parallel lines, corresponding angles, alternate angles, that type of thing. Okay, so these two have to add up to 180. Okay, so that has to be 123. And then I know if that's 123, then angles at a point have to add up to 360. So therefore this has to be 26. Okay, and that's why I've written BCD is 26. Okay, and I believe that's the first mark for this question. I've drawn this line in here to make this triangle, okay, because what I'm going to do is find the length BD, right, which I've called X in this diagram. So I'm going to now use the cosine rule, okay. So I've used the cosine rule, x squared equals 7 squared plus 8 squared, take away 2 times 7 times 8 times cos 26. Okay, so this is a cosine rule on question on triangle BCD. Okay, and you'll find that BD comes out to be 3.512131378 kilometres. Okay, I'm now going to find angle CBD, which is the last one that I needed. So now you can see why I've found this length here. Right, because I've found out some stuff about this triangle, I can then find out more things about this triangle. Right, it didn't tell me to find BD, but through experience and through practice, you realise that I've got a triangle here. If I can find out as many things as possible about this triangle, other things begin to fall into place. Okay, so I want to find angle CBD. So this time I'm going to use the sine rule. All right, so it's because two angles, so two angles use the sine rule, one angle use the cosine rule. Is a general way of deciding is it a sine rule or cosine rule question. Okay, so we've got I've put sine y over 8. Right, we deal with the ones that opposite each other. So sine y over 8 equals sine 26 over x. So again, sine y over 8 equals sine 26 over x. Now again, we know what x is now. So in my working down here, sine y over 8 equals sine 26 over 3.512131378. Okay, I can then multiply both sides by 8 to get rid of this fraction, because there's my only unknown. So I've then got sine y equals sine 26 over 3.5121313 multiplied by 8 gives me this. Do my shift sign to get the find an angle. Remember, if you're finding an angle, you're always going to be pressing the shift key, and you find out that y is 86.89313, and so therefore the bearing of D from B has to be 57 plus this bit here, and we've just worked out that this bit here is 86.89313, so it's going to be 57 plus 86.89 as I've written down here, and we end up with a final answer of 143.9. Okay, And that's the end of paper 3.